Hello everyone and welcome to tutorial number 50 in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. In the last tutorial I discussed about the concept of generics. I gave you a very brief introduction of what generics was and we discussed a few concepts in generics. So in this tutorial I am going to take you to the IDE. I am going to discuss what we have discussed in the PPT, but we have not discussed in the IDE, okay, till now. So we discussed about autoboxing, annotations and all the other concepts which are mentioned here, okay, but we did not discuss them with the help of the IDE. So that's what I'm going to do that in this particular tutorial. So if you're interested in learning these concepts and all, so you can go and watch the previous tutorials and you can get a brief idea of what these concepts exactly are. Alright, then after that you can watch this tutorial so that you will get a clear understanding of how these concepts are going to work. And otherwise, if you are interested in learning the concept of generics, then you can go and watch tutorial number 49, the last tutorial. So let's get started with this tutorial. So first of all, I'm going to talk about autoboxing. Okay, so I've discussed the concept of boxing a lot of times, so I'm not going to discuss it again here. So autoboxing is nothing but like for example, if I write integer, okay, I'm writing integer I equals to 23, then this is known as autoboxing. Okay, because I am storing this value 23, it is an integer value, and I'm storing this primitive data type value inside the object of a type wrapper class. So this is autoboxing. And right now if I print system.out.println I.int value, alright, it is going to print 23. Okay, so that is the concept of autoboxing. So let us wait for the execution to finish. Yeah, it is printing 23. Okay, so that is exactly what this particular thing is going to do. In much the same manner, if I write long equals to long I equals to 23, okay, it is not going to give any errors, but you need to remember that you need to append L here. Okay, this is not going to give any error in the second statement, but it is going to give error in the first statement because 23 is an integer and 23L is a long value, and here you can replace this with long value if you want. Okay, but actually even int value is also defined in the class long, because this class is inheriting from number and all these functions are defined in the number class. If you remember, I also mentioned this in the earlier tutorial. So now I'm changing the value to 89 and I'm pressing the run button. It is going to print 89. Alright, in much the same manner I'm going to use short here. Short, okay, short 89, then I'm going to write short here. Okay, then I'm going to replace this with short. So all of these are autoboxing. Okay, so I'm simply storing this value inside the type wrapper object of a type wrapper class. Okay, so this is how we do it for short, and we do it in much the same manner for byte as well. Okay, so I'm going to replace this with byte, and I'm going to write 124 here. Okay, so I think I need to replace this with byte actually. So I'm going to replace this with byte, and if I press the run button again, it is going to print 124. Alright, so now if I replace this with some other value, like let us say 10,374, it is not going to print 10,374. Okay, please keep that in mind. I have told you a lot of times, it is not going to print 10,374, it is going to print minus 122. Okay, then after this we have I think we have discussed long, int, short, byte. Okay, there are 4 more primitive types. Okay, we need to discuss float. Okay, float f equals to let us say 3.14f. okay, the value of pi value. Okay, then I dot float value So it is going to print 3.14f. Okay, so this is autoboxing. Okay, so whatever we have discussed till now, the first statement was all about autoboxing. Okay, so in much the same manner, if I replace this float with double, okay, and if I remove this f here, then it is going to become a double. So it is going to get autoboxed to I. Okay, and in much the same manner, I am going to replace this with double value here. Okay, and if I press the run button again, it is going to print 3.14. Alright, so this is all about autoboxing. Okay, and if I talk about auto unboxing is also, not that much difficult. So auto unboxing, let us say, I am writing a double, okay, double D equals to I. Okay, so this is auto unboxing. Okay, automatically, it is getting the value of I is extracted and it is getting converted to D. Okay, obviously I can do this as well. Okay, this is also allowed. This is also allowed, but this is also allowed. Okay, so you can do it auto boxing also. Okay, you can do manual boxing also, but as the compiler said, it is going to give you a warning. It is not necessary. So this is auto unboxing. All right, so we can follow the same procedure for the other data types as well. So you can do that from your end. Okay, so I'm not going to repeat all those things now. So then after this, so this was for autoboxing. Okay, so now I'm going to talk about autoboxing in methods. So what is autoboxing in method? Okay, so let us create a let us create a function for that. Int, let us say function. Okay, and I am going to pass a parameter, okay, of integer, which is a type wrapper. Okay, and I am going to return I. So what exactly I am doing here? Okay, what exactly I am doing here? This is auto unboxing. Okay, this is auto unboxing. Obviously I can do I.int value also. Okay, but it is not necessary. Okay, it is not necessary. I can directly do return I and it is going to do auto unboxing. Okay, and here what I am going to do, I am going to write integer I, it is equals to function 23. So this is auto boxing. Okay, so I hope you are getting the concept, because this particular function, it is returning a int data type, and I'm trying to store this value 23 inside a type wrapper, object of a type wrapper. So that means this is auto boxing. Okay, but this is auto unboxing because I am extracting the value which I got from I. Okay, and then after this I am returning the extracted value. Okay, so right now if I write system.out.println, okay, system.out.println I, it is going to print 23. Okay, so this is going to be auto boxing and auto unboxing in a single line. Okay, so here in this function we are performing auto unboxing, and in this particular statement we are performing auto boxing. All right, so this was about auto boxing in methods. Okay, so you can do a lot of variations using this same concept. Okay, so that is completely up to you. Then after this we have auto boxing in expressions. Okay, so what is auto boxing in expressions? Like let us say integer I equals to let us say 125, 145. Okay, so now I'm going to do I plus plus. Then system.out.println I. Okay, so what exactly is happening here? In this statement, it is first of all performing auto unboxing. Sorry, first of all it is performing auto unboxing. Okay, the values extracted from this I. Okay, the value extracted is 145 obviously. Okay, then after that that particular value is incremented. After that the increment takes place, and after that the incremented value once again it is auto boxed. Once again it is auto boxed to the same variable I. Okay, so the value which is printed here, it is going to be 146. Okay, so you can perform arithmetic operations in this manner. Okay, so let us say I'm doing multiplying two integers. Okay, but I am going to do it with the help of a type wrapper. Okay, integer I equals to 12, integer j equals to 13. Okay, integer k equals to I multiplied by j. Okay, then system dot out dot println k. So what is the output going to be? The output is going to be 156, right? So let us wait for the output. Yes, the output is 156. So the thing is, what is happening here? Here also, auto unboxing is taking place. Okay, the value from the I is extracted, the value present in j is extracted. Then after that, both of them are multiplied with each other. Then after that, the resultant value, once again it is boxed to k. Okay, so this is how we can do auto boxing in expressions. Okay, you can do plus here, you can do minus here. Okay, you can do division here. It is completely up to you what you want to do with it. Okay, it is completely up to you. So this was about auto boxing in methods and auto boxing in expressions. Okay, so then after this I forgot to discuss about characters and booleans. Okay, auto boxing in characters and booleans. So if I talk about auto boxing in characters, let us say I'm going to write character c equals to, let us say, a. Okay, so this particular a, it is a character and it is automatically going to get stored in this object of this particular type wrapper class. All right, so now if I write system.out.println and if I write c, it is going to print a, obviously. Okay, so this is in this first statement I am doing auto boxing and here I am doing auto unboxing. Okay, then after this, instead of character, if I write boolean, let us say, okay, let us write boolean b equals to true. So what is this thing all about? This is, the first statement is auto boxing and second statement is a kind of auto unboxing. If I press the run button now, it is going to print true, isn't it? Then much the same manner here, if I write false, it is going to print false. So this is about, this is about auto boxing. Okay, I've discussed all the primitive data types and all the type wrapper. In any case, there are only 8 primitive types in Java. Okay, and there are 8 type wrapper, corresponding type wrapper classes in Java. Okay, so I've discussed all of them. So now that we have finished auto boxing with along with the methods and expressions also. So now let us move ahead. I'm going to talk about annotations. Okay, so as I told you earlier itself, annotation is nothing but metadata. Metadata means data about data. All right, so let us create a new annotation here. Okay, so go to new Java class. Okay, the procedure of creating annotation is much the same as we did earlier. It is same as creating an enum. Okay, creating an interface, creating a class. Okay, so I'm going to write click on Java class. Then after that I'm going to click on annotation. Okay, so if you're using this particular IDE, okay, you need to follow this particular step. First you need to go to file, click on new, then click on Java class. Okay, if you click on Java class, then this particular dialog box is going to open. After that you need to click on annotation. Then after that you need to type the annotation. Okay, your name of the annotation, I mean. Then after that, if you click on the enter button, then this particular thing is going to open. Now if you look at this statement extremely carefully, you can see the difference between the annotation and interface. Okay, let me open this particular interface class just for this purpose. If you look at this particular file, you can see public interface custom. Okay, same we are using here, public interface derived, public interface package. Okay, but if I look at this particular file, it is writing public @interface. @ means I am referring to annotation. Okay, I am referring to annotation. All right, so after this what do we have? After this what we have is retention policy. Okay, now retention policy, it is also kind of annotation only. Okay, and we can write this retention policy in this way, @retention policy. Okay, now if as soon as I type this, what you're seeing, this is defined in java.lang.annotation package. Okay, so one thing you need to remember is that all the most of the annotations which are going to use in Java, they are defined in java.lang.annotation package. So as soon as I click on this particular thing, it is going to import that particular package along with that this is also an annotation. Okay, so then after that I'm going to write retention policy dot. So you have three values here. Okay, retention policy dot source, retention policy dot runtime, retention policy dot class. Okay, so you can write source here if you want. Okay, otherwise if you don't want source, if you want runtime, you can use runtime. Okay, otherwise if you don't want runtime, if you want class, you can use class as well. Okay, so it is completely up to you what you want to use here. Okay, and if you don't know what a retention policy is, then please go and watch the previous tutorial when I discussed about annotations. Okay, so in that tutorial I discussed in detail about retention policy. Okay, so there are three types of retention policies. One is class, okay, and one is source, one is runtime, and it is visible here itself. One is class, one is runtime, and one is source. Okay, so you can go and watch that tutorial in order to understand that what is the concept of retention policy. Okay, so after this we have default values. So what is a default value? As I told you in the previous tutorial itself, okay, when I used the PPT, if you are defining a member in an interface, I mean inside a annotation interface, then that particular member has to be a function. Okay, so int val, okay, string str. Okay, so what exactly am I doing here? I am defining two functions here. One is int val, and obviously since this is an annotation, we cannot have we cannot have definition for this methods. So I'm simply writing int val, then after that I'm putting a semicolon, then after this I'm defining string str, then after that I'm putting a semicolon. Okay, so what is going to happen if I try to define a method, or I try to provide a definition for this particular method? So let us see what happens. So what is the error which it is showing? Interface abstract methods, they cannot have a body. Okay, so that thing is not allowed. Okay, same applies for string as well. You cannot define a body for these methods. Okay, so then after that, if you want to provide a default value, okay, then there is a specific way in which you can provide a default value. First of all, I'm writing int val. Okay, what you might think the way is, you will think that the way of doing this is equals to 23. No, that is not the way to do it. Okay, that is not at all the way to do it. So first of all, you're going to write int val, then after that default, then after that 23. Okay, so this is the way to do it. And if you look at the right hand side, it is not giving you any error. Okay, so this is the correct way to do it. In much the same way, if you want to declare the default value here, you need to write default, then after that you can write, let us say, okay, like annotation or something like that. Okay, so in this way you can provide a default value for the interface annotation interface members. Okay, then after this, marker annotations. If you remember, I told you, in the previous tutorial when I discussed the PPT itself. Okay, marker annotations are those annotations which have absolutely no members inside it. Okay, so this becomes now my annotation. It has become a kind of marker annotation, because I have removed both the methods which I had defined right now inside it, and it has become a marker annotation. Okay, and if I talk about a single member annotation, then this is a single member annotation. Okay, there is exactly one value inside it, and if you remember, I told you one additional thing. Okay, it should be named as value. Okay, that is another thing which I told you, when I used the PPT, if you remember. Okay, so now this my annotation, it has become a kind of a single member annotation. Okay, then after this we have built-in annotations as well, but I'm not going to discuss these annotations right now. So first of all, let us use the annotations which we have used till now. Okay, so I have defined this annotation here, my annotation. Okay, And after this I'm going to use another annotation, which we discussed in when I used the PPT, if you remember, target annotation, if you remember. Okay, so at the rate target dot target. Okay, so no, it is not at the rate target is not target. Wait a minute. Element type. Okay, element type. Okay, fine. So element type dot, what is happening here? Okay, it is not importing element type. Import java.lang.annotation dot element type. Okay, so element type got imported. Now I'm going to write annotation type. Okay, so what is the meaning of this annotation type? Okay, so now I have put this used this particular annotation at the rate target element type dot annotation type. That means this particular annotation, it can only be used on another annotation. Okay, so right now this is a class, so let me try to use my annotation over here. What is going to happen? It is going to give an error. Okay, it is not applicable to type, right? Because here I have written that this target is going to target only annotation type. That means this particular my annotation, it can be used only before annotations. Okay, so let me explain it over here. Let me create another annotation here at the rate interface custom annotation, or let me write example. Okay, so it was creating error there. I think it is going to create error here as well. Duplicate first. Okay, it is example. Okay, examples. Okay, so now what I'm going to do here is I'm going to write at the rate my annotation here, my annotation. Now if you look here, it is not giving you any error. The reason why it is not giving you any error is because this particular line, it is telling the compiler that this annotation can be used only on another annotation. Okay, so that is the meaning of this particular statement. Okay, so then after this, what do we have? Okay, so that is the meaning of this particular target element type, that annotation type. Okay, then after this, if I change the annotation type to type, okay, then if I return here, the error is removed. Okay, so the reason why the error is removed is because at the rate target element type, the type means it is going to target all types. So it can be used in in front of class, it can be used in front of, let us say, here also it can be used. It is not going to give you an error here. It can be used in front of enums as well. Okay, it can be used everywhere. Okay, because it can be used in front of a type. Okay, so now I'm going to remove all those things because it is going to give an error in the future. Okay, so I'm going to remove all those annotations. Then after this, I'm going to write element type dot constructor. Now as the name itself suggests, and I think you would have guessed it by now, this particular interface, this particular annotation, it can be used only before constructors. Okay, so for example, here I'm going to declare public tutorial. Okay, now remember, this particular class, it is declaring this annotation, but this has not been used anywhere till now. Okay, it is being used here only at the rate my annotation, and you can see there is no error absolutely whatsoever, because I have told the compiler that it is going to target a constructor. So in front of a constructor, before a constructor, I am going to write this annotation. Okay, so that is how this particular thing is going to work. Okay, then okay, so right now if I write this at the rate my annotation here, it is going to give an error. Okay, it is not allowed. Okay, then much the same manner, if I write field, okay, so then this will be valid only in front of fields. So by field, what I mean is, like for example, public int I. Okay, this is a field. Okay, so if I write it here, then it is not giving you any error. All right, then after this, what do we have? What are the other things we have? We have type use. Okay, so you can see, what is the usage of this particular type use. Okay, so it is not giving you any error here also, it is not giving you any error here. Okay, so there has to be some difference. I think I will look into this difference and tell you later on that what is the difference between type use and field. Okay, so let's go with the remaining part. Then after this we have local variable. Now as the name itself suggests, I think this should be very clear to you. It is used in front of a local variable. Like for example, I'm writing int I here. Okay, and here I'm going to write @ my annotation. It is going to be perfectly valid because it is valid only in before a local variable. Okay, in much the same manner, what else do we have here? Okay, it is very interesting actually. If you keep exploring, it will be very, very interesting in front of a method. Obviously now this thing is going to be valid in front of a method. I'm going to write my @ my annotation here. Okay, and it is valid here. Okay, but it is not going to be valid here. Okay, so then after this, what are the remaining things? Package parameter. Okay, in front of a package. Okay, so this is the package, and I'm going to write @ my annotation here. I think it is not valid. I think package annotation should be in file package info.java. Okay, so that you need to keep that thing in mind. So we are not much concerned about package because generally they are not used. Okay, but it may be used in certain programs. Then we have parameters, we have type parameter. Okay, so if I'm talking about a parameter means I'm talking about a method, right? So let me use here. If I write @ my annotation, then it is perfectly valid. Okay, because I've written it is going to target a parameter. Okay, then after this if I write @ okay, I'm not going to write @ there. I need to change the value here. Element type dot type parameter. Okay, now if you don't know what a type parameter is, please go and watch the tutorial number, I think the last tutorial. I have discussed I've given you brief introduction of generics there. Okay, so here let me try to use @ my annotation. Okay, so this is what is a type parameter. Okay, so this is the concept of generics, and if you don't know what generics is, I am repeating, please go and watch tutorial number 49, the previous tutorial. Okay, so it is going to target a type parameter, and here it has targeted the type parameter. Okay, there are a lot of concepts actually in the annotation, but the time is not sufficient to discuss all of those in this particular tutorial. So we have discussed till this particular single member annotation. Okay, but we will be discussing the usage of marker annotation and single member annotation in the next tutorial. Then after that we will be discussing the built-in annotation, and we will be trying to use the reflection. Okay, how to use reflection to get the knowledge from the annotation. Okay, because annotation go hand in hand with reflection. Okay, so that's all I'm going to talk about in this particular tutorial. Okay, if you have any kind of questions or any kind of doubt, then don't forget to post in the comment section below, and I will get back to you when I can. And if you liked this particular tutorial, then don't forget to like, share and subscribe, and yeah, I will see you in the next tutorial. So till then, bye.